All right, in the last video, we looked at long division, using long division to divide two polynomials where the denominator, the divisor was not a monomial, so there was a plus or a minus involved in the denominator. Now we're going to look at something called synthetic division. Synthetic division is it's the same concept, same idea, actually has a lot of the same parts to it. It looks vastly different, and I'll try and explain why and how it comes to be. But essentially, it's a shortcut. It's an algorithm that allows us to divide polynomials fairly quickly. And some of you are going to like it, some of you are not. And I mean, that's just the way I found it to be. That some people really seem to like this and gravitate to it. Some people really don't. The first one is probably going to feel really weird because it seems almost magical isn't the right word. That sounds great, but it's going to seem like just doing things randomly. As we do more examples of it, and as I show you kind of a side-by-side of synthetic and long division, I'm hoping you'll at least see where it comes from. You will be asked on the test to do one problem with synthetic division, and you'll be asked on the test to do one problem with long division. So you need to be at least familiar or capable of doing both, regardless of which one you prefer. Here's what we're going to do. We're going to take the inside here, the numerator of our fraction. We're going to take this, and we're going to only look at the coefficients. So we're going to ignore all the x's. So we'd have a 2 here, we'd have a -5 here, a 2 here, a -3 here, and the leading coefficient here is 1. So if we do that, excuse me, there are my coefficients. And I'm going to take what I'm dividing by here, a divisor, and I'm going to write the opposite of this number. I'm going to say that again. If it's like an x plus 5, you put a -5. If it's an x minus 1, you're going to put a +1. And so we're just really looking at what this number is if it's x minus this number. I'm going to write that right over here. I'm going to put a little box around it. Again, it's already starting to feel a little arbitrary, but we're bringing these numbers down. We're taking the opposite of this number, so -1, we put a 1, and I'm going to draw a line right here. And now we're going to start. So I've set up the algorithm here. I've set up the division. It's all I've done so far is I've set it up. And this is how it works. And I'm gonna try and work through it slowly with you. I'm going to do another 2 or 3 examples. We're going to take this first coefficient and we're going to bring it straight down. I would recommend drawing the arrow, at least for now. And then I'm going to take my divisor here, 1. And I'm going to do 1 times 1, which is going to give me 1. And I'm writing the 1 right here. So you bring the first number straight down. You can do whatever this is. 1 times 1 equals 1. And now we're going to add these together. So -3 plus 1 is -2. Now I'm going to take my divisor 1 times -2. 1 times -2 is -2. So I'm going to write the -2 right here. I'm going to add. 2 plus -2 is 0. I'm going to keep this process going. 1 times 0 is 0. -5 plus 0 is -5. 1 times -5 is -5. 2 plus -5 is -3. Once I finish doing all that process there, whatever's left over is my remainder. So I'm going to put a little box here to remind myself that this is the remainder. So I've got a remainder of -3. So when you do all the division, you're going to get some polynomial, and there was a remainder. And so in this case, we had a remainder of -3. Now I'm going to write my answer. So the way this works is the negative for the answer, the -5 is the constant. I've got 0 x's, -2x squareds, and 1x cubed. So again, where I got this solution, this answer here, is these numbers right here. I've got -5 as my constant. The first one on the right is my constant. 0 x's, -2x squareds, or -2x squareds, and 1x cubed. Again, that remainder of -3 was out of x minus 1. And so I have -3 out of x minus 1 as the remainder. Now, if you write this, XYZ homework may or may not, I'm not positive, I got to check, accept it as it's stated here, simply because you don't really need to write 0 x's. It's not necessary to write them. And so that's important that you would probably leave that out. I'm 99% sure that if you wrote 1x cubed, XYZ homework would accept that just fine. Same thing with this right here. In the textbook, if you look at it, the way the textbook writes plus -3 over x minus 1 is it writes it as minus x, or 3 over x minus 1. And so this is the way you would see the answer in the textbook. And that's why I'd recommend writing it down. Technically, it's not wrong to write that there are 0 x's. However, it's not necessary. Same thing with the 1 as the leading coefficient here. So this would be our final answer. That's the division. That did not feel faster because I went through very slowly. So let's try another example here of synthetic division. So we're going to divide x to the 5th minus 1 divided by x minus 1. When I see a something minus something else, I always check right away, is it a difference of perfect squares? 5 is not 1, 1 is. X to the 1 is not 1. So it's not quite, I can't do any much with that. So I'm going to divide it. If you set it up for long division, it would look like this. Now this is where we have to be careful. There are, in fact, I'm going to, no, I'll say it. To do this, for either of the divisions, you have to have a placeholder for all the descending powers of x. So if it goes x to the 5th and then skips straight to x to the 0, which is this 1 here, constant of 1, x to the 0, you're skipping x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. There's a lot that you're skipping in there. And when we're doing any kind of division, whether it's long division or synthetic division, we need to account for that and have a placeholder. So we would say we have 0x to the 4th, 0x cubed, 0x squared, 0x. So the synthetic division would start out like this. We have, or the long division, but we would start off with, we have 1x to the 5th, 0x to the 4th, 0x to the 3rd, x squared, x minus 1. And again, here my divisor of minus 1, I'm going to take the opposite of 1. So that's the setup. I'm going to go over to my document camera. Let's do this division. So again, it was, I'll write down here, x to the 5th, 0x to the 4th, 0x to the 3rd, 0x squared, 0x minus 1. And so that was, if you expand that all out, so my synthetic division, 4, 3, 2, 1, and -1 is my last part. So there's my synthetic division. We pull the first one straight down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -1 plus 1, 0. So all that process there gave me was that I have a 0 remainder, and the coefficients, all these 1s here are the coefficients of my solution. So this is going to be my constant. I've got 1x, 1x squared, 1x cubed, and 1x to the 4th. And there was 0 remainder. So dividing, if I had done long division, I would have gotten the same result. X to the 4th plus x cubed plus x squared plus x plus 1. You can always double check that and see if I'm telling the truth by doing it. But that's synthetic division. And you can see that you just bring it down and you start multiplying and adding, multiplying and adding, multiplying and adding. Multiplying and adding tend to be faster and quicker than dividing, but it kind of depends. So that's the answer. That's the solution. Back in here. There we go. There's the solution. There you go. We got a remainder of 0. Okay, I'm going to look at three different theorems here. I'm not going to ask you specifically what does the remainder theorem for division say, but we're going to use it, and I'll show you how to use it as we go. But I want to make sure that you know what we're doing. So what this first theorem here says is if you take any polynomial and you divide it by x minus r. So that's a lot like dividing by x minus 1. R in this case would be 1. Then the remainder is going to be p of r. What this says is if you take, if you're dividing by x minus something, and you plug this number into the function, the remainder is going to be whatever you get. So if I took 1 and I substituted in here x to the 5th minus 1, I should get 0 coming out because the remainder was 0. And sure enough, that works. Back here, if I took 1, because that's what I was dividing by, x minus r, 1 was r, and I plug it into this function here, 1 to the 4th minus 3 times 1 to the 3rd, etc., 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 I should get negative 3 that comes out. So you can always find the remainder quickly. If you want to know, will there be a remainder, you can plug it into the formula, or plug it into the polynomial, excuse me, and see what the remainder is going to be. And so that's what that first remainder theorem for division says, is if you plug the number you're dividing by into the original polynomial, you get the remainder. If that remainder is 0, that means that x minus r, whatever this number is a factor of the original polynomial. And that's going to be really useful. If we take this number, we plug it into the function, and we get 0 out, we know that x minus r is a factor of that original function. So if I were asked to solve this or factor, like this said equals 0, and I wanted to factor this, because x minus 1 gave us a result of 0, that means that I can factor this out of x to the 5th minus 1, which is really what I did here. When I divided, I factored it out, and this was what was left. We'll use that in future problems, I promise. The last thing here just says that if it is a factor, if this holds true, where p of r equals 0, then r is a 0 of the solution. So when you graph it, whatever this number r is, is where the graph crosses the x-axis. It's a 0 or a root. Okay, so we're going to solve an equation. We're going to find all the solutions to this polynomial if x equals 3 is one of the solutions. And this polynomial here should say equals 0. So it's missing the equals 0. You can add that in right now if you want. But we're going to say if this was equal to 0, if we set this equal to 0, what could x be? So this is a cubic. Now on the chapter 2 test, I told you that if you saw a cubic, it was going to be where you could factor it by parts. This one, not so much. 15 and 61 don't have anything in common that you can really factor out, minus 1, but it doesn't work to factor this by in parts, or factor by groups, excuse me. So we're going to have to use a different method. What this theorem says here is that if x equals 3 is a solution, if r is a solution to this equation, then we should be able to factor it out. So if x equals 3 is one of the solutions to this equation here, that means that x minus 3 is a factor. It's going to be minus simply because that's what this is, x minus r. I'll leave that up for a second. Pause it if I'm moving too fast for you. So here's my original function, my original polynomial, and I was told that x equals 3 is one of the solutions. If x equals 3 is one of the solutions, you should be able to plug 3 in for x here and get a 0 when you add them all together. And we should be able to factor out an x minus 3. And factoring out is dividing. We're finding the common factor by dividing. Okay, so I'm going to move over to the document camera. We're going to divide this. I'm going to do it in two different ways. I'm going to do a long division and synthetic at the same time, just to kind of show what that looks like. So if here's my division, my divisor is going to be a positive 3 here because we take the opposite. And I've got 8, negative 2, I've got 3, 2, 1, 0. Yep, I've got all my x's in there in order. So 8, negative 2, negative 61, and negative 15. Okay. So if I do the synthetic, I'm going to bring the 8 down and do 8 times 3 is 24. If I add those together, I get 22. And then we keep going. Let's move back over here for a minute. For long division, so I'm asking something times x is going to give me something close to 8x to the third power. Well, 8x squared. 8x squared times x give me 8x to the third. So then 8x squared times 3, 24x squared. 8x squared times minus 3, negative 24x squared. Here's that 24 popping up right there. If I subtract 8x cubed minus 8x cubed is 0. Negative 2x squared minus a negative 24. So subtracting a negative is like adding. I get 22 squared. Hey, there's that 22. So these numbers are not coming out of nowhere. They're really coming from this long division. It's just a faster way of doing it. Let's do one more step over here, and then we'll move back over to the synthetic. So I want to know something times x gives me 22x squared plus 22x. 22x times x is 22x squared. 22x times minus 3 should give me a minus 66x. Subtracting. 22x squared minus 22x squared is 0. Negative 61x minus a negative. So again, I'm subtracting a negative. That's like adding 66. I get 5x. Let's move back over here. Let's see if we get a 5 out of this. So 3 times 22, 66. Negative 61 plus 66 is 65, sure enough. Oop, I'm sorry, not 65. 5, sure enough. Last step, I bring the minus 15 down. And I'm going to ask something times x is 5x. 5 times x is 5x. 5 times minus 3 is minus 15. And I should get a remainder of 0 because I was told that 3 is a solution, which means that it should give me a remainder of 0. 3 times 5 is 15. 0. You can see how this is a faster method once you get the hang of it than what we did over here. This tells you everything that's going on. This just takes it as a shortcut. So the solution here, 8x squared plus 22x plus 5. They match. So that's both the synthetic and the long division side by side, so you can see where those numbers come from. Sadly, that's not what the question asked, is it? The question said find all the solutions. We know that x equals 3 is one of the solutions. We just did some division. We factored that x minus 3 out of the original polynomial and got this. But we're not done. Right? We don't know all the solutions. We just know one of them. It could be that x is 3, which we already had, or something else. We have this second degree polynomial, this quadratic polynomial. All right, let's go back to the document camera then. We're not done. Okay, so we have this. There it is. What we just figured out. X minus 3 was one of the factors, and we factored out and got this. So now we need to factor quadratic, the quadratic. So I'm going to use the rainbow method that I call it. The way this worked is I ignored the 22, and I find two numbers that multiply to 5, 5 and 1, and I need two numbers that multiply to 8. I'm going to go with 2 and 4. 2 times 4 is 8. I do the rainbow, taste the rainbow. 4 times 5 is 20. 2 times 1 is 2. If I have the right numbers, because this could have been 8 times 1, in the right order, then I should get the same number to match here. And it does. So now I can make my factors. This one comes straight down. 2x crisscross in the middle, plus 5, 4x plus 1. If you do factoring by groups, if you use the AC method, which is pretty much the same thing, that's fine. But now I have my three factors. I've got x minus 3, 2x plus 5, and 4x plus 1 equals 0. And since it was a third degree polynomial to start with, 8x cubed is what we started with, I should have three different roots in the end. And we're going to talk about that later on as well. So I know that x could equal 3. That was given to me. If you solve this for 0, remember we're using the zero product property. If you solve this for 0, you're going to end up that x could equal negative 5 halves. If you solve this for 0, we would have that x equals negative 1 fourth. So those are the solutions to that original problem. There's a lot more work. We're kind of tying in a lot of different material that we've covered so far, but those are the solutions. So first we factor out the x minus 3, factored, and found the solutions. There they are. All right, I'm going to stop. I'm going to ask you to try these two on your own. I'm going to do a follow-up video for each of them. The first one says divide those two polynomials. The second one here says find all the solutions to this equation. Pretend this has equals 0. X cubed minus 4x squared plus x plus 6 equals 0. I'm telling you that one of the solutions is that x equals 2. Try these two on your own, and I'll show how to do them in a follow-up video. Actually, I take that back. I do have the solutions. So if you got the right solutions, then you don't need to watch the follow-up video. If you did not get the right solutions for that, then watch the follow-up video, see how to find those answers.